Hi everyone. This is a video that summarizes some of the key parts of the course we have been talking about so far. And as a recap, I want to introduce this idea of the piston. This is a device we have been using to motivate a lot of the properties and processes that we have been talking about throughout most of the first part of the course. And the basic parts of the piston really are, well, the boundary that we introduce here. There is the movable part that forms the action of the piston itself, and this can move up and down unless we constrain it by some blocks or some immovable parts right here at the edges. The third part of the piston is this overall space that's inside, and we always assume that there is some gas or material or something inside it. Now, as we have been learning, these gases or these fluids have several properties that we assign to them based on their work and that they can do. And really, what we are interested in are the following properties: their internal energy, their entropy, their temperature, their pressure, and ultimately also their volume. Now, if we make a diathermal wall, that basically means that we are working in a adiabatic system so that no heat can escape, so that del Q is zero. Let's assume we have our example of the paddle wheel. So we introduce a paddle wheel in here, and now we begin to spin it. And what we do as we are spinning it is really we are introducing a greater amount of energy. In other words, our energy is going to change. And so what we can do is for the system that we know is adiabatic, hence this designation here, we can really begin to talk about the delta U, or the change in internal energy, and the deltas of the system. Now, what we can also begin to do is consider the case, as we considered it on the previous slide, where the internal energy changes, specifically where it increases. And so what we know is that by introducing in a greater amount of internal energy, we are essentially also introducing a change in the overall entropy of the system. The entropy of the system has to increase in this case. Now, let's consider a different case though. What happens when the delta U decreases? And so this is actually a little bit of a trick question, because there is no way to take out the energy out of a system that is completely isolated. And so this really doesn't matter at all.